Hello, yeah, in this video, I will show you how to perform cluster analysis using the Mclust package in R. So, roughly speaking, we have three classes of clustering analysis methods. We've seen the hierarchical clustering implemented in the Hclust. We have seen partitioning clustering implemented in cluster. And also we have the third approach called the model-based cluster analysis. So basically, in this approach, we assume the data comes from a mixture distribution. So the data just does not just come from one distribution, but it's actually from multiple distribution mixed together. Okay, so it's called a finite mixture theory, which is a very rich but very interesting body of statistical models. Okay. Okay, so here let's start it to load the Mclust package. Also, we need the mass library also, and let's set a random seed. And then we generate a synthetic data set. So number of clusters, let's say 3, number of points, 300, and dimensions, 3, the number of dimensions, or we say there are 3 variables, okay? And we define means and the covariance matrix for the clusters. And then cluster covariances, specify 3 matrix here. And then we can generate data for each cluster. And then we combine this into one data set called the synthetic data. It looks like this. Okay, so this is a 300 by 3 data matrix. We have 3 variables and we have 300 data points. Underneath there, they come from 3 clusters. Okay. Then we can, since we created the data set, we can have the true labels here. And then we can visualize the generated synthetic data set look like that. So they're separated pretty well. And to run the Mclust for model-based clustering, the syntax is Mclust. Please pay attention here. M is capitalized. Okay, so Mclust synthetic data. Okay, and it very quickly it finished the computation, and we can take a look at the summary. You can see it tells us it's a Gaussian finite mixture fitted by EM algorithm. So the underneath model is a mixture of normal distributions, a Gaussian mixture. Okay, and the estimation method is the EM algorithm. So we do have maximum likelihood estimates. And once you have the maximum likelihood estimates, you can have the log likelihood statistic. You have BIC and ICL, those kind of goodness of fit indices. Later on, we can use for model selection. Okay. All right, we can do visualization of the method using just the plot function and plot the Mclust model, and is as a what equal to classification dimensions 1 to 2, and the title is cluster classification using the first 2 dimensions. Okay, so it looked like that. Okay, so you see the 2 dimensions there inside of the oval shapes, and look like that. And we can also plot out the BIC values, the BIC plot for model selection. Okay, so it looked like that. You can see it get a bunch of models called EII, VEE, VII, EVE, etc., etc. What this means is it basically it evaluate all these potential covariance structure, and there's three things we look at. One is the volume, and the other is shape. The other is orientation. Okay, so the EEE means equal, equal, equal. So meaning the clusters have equal volume, equal shape, equal orientation. And VVV is a variable, variable, variable. So they have different volume, different shape, and different orientation. Okay. And so this BIC really shows, help us to really select the optimal cluster here. You can see the x-axis is the number of components, and then you got the BIC value over there, and you can see it really the three components is kind of the really reach the peak, and it goes up and then goes down or almost stay flat. Okay, so the three cluster is the optimal model we should choose. And also we can generate density estimation. So here's the plot, the Mclust model, what equal to density. It will look like that, okay? And then the uncertainty plot for the first two component look like that. And then you got, you can do discriminant analysis using the function Mclust okay? So you can use the synthetic data set, but then you use the true labels, and you can print out the summary. You can see the confusion matrix is there's only one misclassified case, so the classification error is 0.0033. The Breyer score is also very, very small, so it's a very accurate classification here. Okay, and you can plot out the discriminant analysis result, look like that. So scatter plot from discriminant analysis. So they're pretty well separated, except that there's one data point, okay, which was misclassified. And another way we can use the cluster analysis result is we can predict cluster membership for new data using the discriminant analysis. Okay, so it's create a new data set. There's 3 new data points. And then we can use the prediction, just using the command predict, and the Mclust DA discriminant analysis object, and the new data equals the new data. And then we can print out the classification result. You can see there's the probabilities for the new observation to fall into cluster 1, cluster 2, cluster 3. So you pick the one with the highest probability. Okay. You can visualize new data on the scatter plot, projecting into 2-dimensional for simplicity. So this is what it looked like into the new 2-dimensional graph there. Okay, you can do density estimation using the density Mclust, and then doing the summary, and then you can plot out the density estimates in 2-dimensional, look like that. Okay. And you can see in like the right top right graph, there are two density plots have some overlap. That's where it's difficult to cluster certain data point there. Okay, and you can plot out the density for new data point, new observations. Okay, and also the Mclust package has Bootstrap inferences. This is really important because cluster analysis is somewhat inaccurate, not exact. So we want to be able to assess parameters uncertainty. So it's very easy to use Mclust Bootstrap, and you can put in the cluster model object in there and mboot. Let's just do 100 Bootstrap, and then we can print out the summarized result, and we can actually print out the Bootstrap inferences confidence interval for the means. Look like that. We got 3 component means. It look like it's concentrated on the mean value, and then you get the confidence interval surround it. Okay, so you can see for example, the mean for component 3 on the second row, the third column. You can see the uncertainty is larger because the shaded area is wider. Okay. Similarly, you can also plot out the confidence interval for the variances, okay, to give you the point estimate and then the Bootstrap distribution, and then you get to the confidence interval, okay, around the mean value there, okay. And we can also evaluate clustering performance to compare the predicted clusters to true labels. Since we use the simulated data set, we know the true labels. Okay, doing that. And then we have this called ARI, or adjusted rand index for performance evaluation. You can calculate using the function adjusted rand index, and then print it out. It's 0.9899832. So the ARI value, if it's close, it's 1, then it's perfect. Okay, meaning it's identical to the true labeling. If it's between 0 to 1, then better than chance, but not perfect. The closer to 1, the better. And if it's 0, then it's like a random clustering. Okay, and if it's less than 0, then something is really worse than random clustering. This is unlikely to happen. But if it happened, then something weird is going on. Okay. So if you read the help documentation for Mclust, you can see there are way more information than what I just covered. Okay. So this is really an introduction to the Mclust package, the model-based cluster analysis, okay, in R. Thanks for watching.